हेलो। हेलो
यस
सर।
अनंत। यस अनंत।
क्लास नहीं करेगा? कोई नहीं करेगा क्लास सर?
कोई तो नहीं कर रहा है बाबू। देखो क्या, इसी तो हम वेट कर रहे थे, कोई आएगा तो। चलो
आने
आए
किसी
तो
को नहीं
कर लो।
पता होगा अभी तक।
ग्रुप
हाँ,
इसलिए
मैं
तो
अकेले
ग्रुप
क्या
में
करेंगे? हाँ, मैं अकेले क्या करेंगे?
तुम्हारी इच्छा, हम तो पढ़ाएंगे बट
अकेला नहीं,
अगर
अकेले छोड़ दीजिए सर, नहीं तो आज। हेलो।
छोड़ने सामने नहीं चलेगा।
हाँ, तो सर
आयो तो
कोई
पढ़
आएगा
लो,
तब ना।
आयो तो पढ़ लो।
ठीक है सर।
So in the last session, we were discussing about the V upon F control, or you can say frequency control. Up to this, we have seen that with the to maintain the value of the speed, we have to maintain the flux value. Otherwise, the saturation will take place in the rotor part. So if we decrease the frequency flux, flux will increase because flux and frequency is inversely proportional to each other. But at the same time, if we decrease the voltage flux, this is the flux. If we decrease the voltage flux, that means flux is directly proportional to voltage. If we decrease the voltage, the flux will be decreased. So that means the if we if the this is the flux is directly proportional to V upon F ratio. As you can see in the right hand side, the ratio taken out 1 upon 4 kT into V upon F. That means if you decrease the to maintain the value of phi constant, if you decrease the frequency, you have to increase the value of V as well, and the vice versa. And that means if you increase the value of frequency, you have to decrease the value of voltage. So in that way, the flux will remain constant. So to keep the ratio of V upon constant, that is because of this V upon F method, V upon F ratio, this is named as V upon F method. Okay, because of this ratio, voltage upon frequency. So to control the speed of the induction machine using this method, is have to use variable voltage source and frequency. That means if we have the equipment to vary the voltage as well as the frequency, then only the induction machine speed can be controlled by the frequency method. Okay, so it will be very much easy if we use mainly this is variable frequency, which is mainly obtained by using converter and inverter section. Okay, by using converter and inverter section, if we use, then we can make the value of the ratio V upon F constant, and that way the flux will be remain constant. If the flux will remain constant, the voltage, or you can say the speed can be controlled. Speed can be controlled by using the voltage upon frequency control method. Now the second method is your controlling supply voltage. Second method is your controlling of the supply voltage, that we have discussed in the previous in the last section, in the last class. The third one is changing the number of stator poles. Number of the stator poles means this formula is related. This is related with this equation. N is equal to 120 F upon P. Okay, if we change the number of poles, stator poles, the speed will vary. That means with the, as ns is inversely proportional to number of poles, if we increase the value of the number of poles, the synchronous speed will decrease. That means if p is increasing, then ns will decrease, and if p is decreasing, then ns will increase. In that way, the change the number of poles can. First method wo ho gaya. Second, if the changing the number of stator poles can be done by your these methods. That is first one, the multiple stator winding method, and second one is pole amplitude modulation method. That is PAM. Just you have to know this your methods. You don't have to elaborate these two methods. Just you can use the, if we want to change the value of the number of poles in the stator, then we have the two methods. That is first one is a multiple stator winding method, and second one is your pole amplitude modulation method, or you can say PAM method. Okay, PAM. PAM method is mainly used to change the number of stator poles, and here also, if we use multiple stator winding method, then also we can change the value of the stator poles. So these are the two methods through which you can change the value of the speed of the induction machine. Now the another method is to adding rheostat in a stator circuit. Rheostat means if we can vary the value of the stator resistance, that is Ra. If we can vary if we can vary the resistance value in the stator part, then also we can vary the applied voltage, or you can say speed can be controlled. So according to this method, the speed control of three-phase induction motor is added in the stator circuit. Due to this, applied voltage gets dropped. Okay, as we increase the value, as we increase the value of the induction machine, as we increase the value of the resistance, that means the voltage drop will increase, and as the voltage drop will increase, the as we have discussed in the torque and slip and voltage term, that is this, if we decrease the value of voltage, that means if we have to increase the value of slip, and if we increase the value of the slip, the synchronous speed will decrease. That means V2 is directly proportional to your speed. That means if we increase the rheostat value, that means voltage drop will be higher, and if the voltage drop will be higher, then the speed will also increase. Okay, in that way we can use the rheostat for the speed control of the induction machine. That means it is written, if we decrease the supply voltage, torque will also decrease. That means if we decrease the supply voltage, the torque will decrease. But for supply for the same load, that means torque will remain constant. If the load does not change, if the value of the load does not change, the torque will remain constant. And for that case, if we vary the value of the voltage from higher to lower level, the slip will vary from lower to higher level. And in that way, the speed, or you can say with the spec, with the reference to slip, we can vary the value of the speed of the induction machine. Okay, so these are the some methods through which we can say that we can control the speed of the induction motion motor with the help of stator part. In from the part of a stator, we can control the speed of the induction machine. So this is the first method, that is stator part method, and second one is your speed control from the rotor side. Speed control from the rotor side. First one, it is adding external resistance on rotor side. So in previous classes, we have studied some your soft starter. We have studied in the last class. In that scenario, in that case also, we have included a rheostat or external resistance in the outer part or rotor part of the induction machine, through which we have controlled the starting of the induction machine. In that way, the same similar manner, you can control the speed of the induction machine by including your resistance in the rotor side. As we are including the, as we are adding external resistance, that means we are increasing the voltage drop, or you can say we are decreasing the value of the current. Because if we increase the, this resistance will be connected in series with the rotor circuit. That means if we increase the value of the rotor circuit by including the resistance, that means we are decreasing the flow, we are decreasing the value of the flow of current. And if the value of the flow of current decrease, the torque that will be, the torque that will develop will also have the less amount of value. That means if the value of the rotor decreases, the speed will also decrease. So in that way, if we add in the starting condition, what happens in the starting condition, all the resistance that we have added in the rotor part is connected in the rotor circuit in the series connection. That means at the starting condition, all the resistance are connected with the rotor part, so that the less amount of current will flow, and the speed will the torque, or you can say speed, will remain less. But as the speed gains, as the time passes, we disconnect the resistances one by one, just like your 4-point starter or 3-point starter in the DC machine. Okay, in that way, if we decrease the value of the resistance time to time, that means uh, we cut out the resistance one by one within seconds. That means you are giving the rotation of the rotor, you are increasing the value of the rotor of the rotation of the rotor. That means you are increasing the your speed of the induction machine. In that way, if we are increasing the value of the speed, that means torque will also increase. So finally, we can say that in the last case, the condition at which the machine attains at its full speed, we totally disconnect the external resistance from the rotor circuit. Okay, so here it is explained theoretically. You can see that in this method of speed control of 3-phase induction motor, external resistance are added on the rotor side. External resistance are, how you can add the external resistance? By including the rheostat part. By including the rheostat, or you can say variable resistance, you can add on the resistance on the rotor side. Now the equation of the torque of the induction machine is given by this equation. That is, this is torque is directly proportional to S E2 square R2 upon R2 square plus S X2 ka whole square. If you replace this proportionality constant with the equivalent sign, then it will become 3 upon 2 pi ns. As you can say, we have dealt with. No, in the previous class, I have told you, if you replace this